Hello, everybody. Today, let's divide the rational expression that says p squared minus 4p minus 21 over 2p squared minus 7p minus 15 over p squared plus 3p over p squared plus 4p minus 45. Now, notice that we have a fraction with a fraction in it, which is called a complex fraction. So this thing that we have to simplify is called a complex fraction. And complex fractions can be rather confusing, but the trick is to break it down into what are called simple fractions. And a simple fraction clearly has one numerator and one denominator. So let's see if we can do that. Every complex fraction has a main fraction line, and the main fraction line is either the longest line or it's a boldface line. So let's figure out where the longest line is. The longest line is this middle line right here. And that main fraction line is the same as division. So we're going to rewrite this as a division problem. So we have p squared minus 4p minus 21 over 2p squared minus 7p minus 15 divided by, and now the bottom fraction, p squared plus 3p all over p squared plus 4p minus 45. All right, now to divide two fractions, we multiply by its reciprocal. So to do that, we're going to copy down the first fraction just as it is. So p squared minus 4p minus 21 all over 2p squared minus 7p minus 15, and then times. And then we want to get the reciprocal of the second fraction, p squared plus 3p all over p squared plus 4p minus 45. To do that, we interchange the numerator and denominator. So p squared plus 4p minus 45 will go on top. And p squared plus 3p goes on the bottom. Now it's a multiplication of fractions problem. To multiply two fractions, it's easier to simplify first and then multiply. To simplify, we want to factor each of these polynomials down. So let's first try to factor p squared minus 4p minus 21. Now to do that, we need two numbers that add to the p term, which is negative 4, at the same time, multiply to the coefficient term, which is negative 21. So can you think of two numbers that add to negative 4, but at the same time, those two numbers multiply to negative 21? If you can, that's wonderful. If not, it's okay. Let's use symbollab.com to help us. Let's go. And it tells us p plus 3 in parentheses times p minus 7 in parentheses. Okay, so let's double check that these are the right numbers. We have 3 and negative 7. 3 plus negative 7 is that negative 4? Yes, it is. And 3 times negative 7 is that negative 21? Yes, it is. So those are the right factors. Now let's go down to 2p squared minus 7p minus 15. Now notice that in the p squared minus 4p minus 21 that we just did, the coefficient of p squared was a 1. And if it's a 1, we can think of two numbers that add up to the p term, in this case, negative 4, and at the same time multiply to the coefficient term, which is negative 21. So here, in 2p squared minus 7p minus 15, the coefficient of p squared is a 2, um, which is more complicated to deal with. So let's just use symbollab.com to get the answer. Let's go. And tells us 2p plus 3 times p minus 5. Let's double check that to make sure that's what we have. 2p plus 3 times p minus 5. Okay. Now there is a long way to get this, and I'll go through the long way at this time. So we take the 2p squared. Okay. We'll move the 2 to the negative 15 and multiply them together. And that's going to be p squared minus 7p minus 30. Now that we have nothing in front of p squared, we can think of two numbers that add to negative 7, but multiply to negative 30. All right. And I kind of think of any two numbers right off the top of my head. So let me just do it on Symbollab. And we get p plus 3 and times p plus 3 times p minus 10. And those should actually work out. And here's what we do now. So we move the 2, so we're going to divide both 3 by the 2 and negative 10 by the 2. And then becomes p plus 3 over 2 times p minus 10 over 2 is 5. Now we can have a fraction in the answer. So what we do is we're going to move the 2 back in front of the p. And then we get 2p plus 3. And there's no fraction of p minus 5, so we don't have to worry about that for that one. Okay, so that's the long way of how they get 2p plus 3 times p minus 5. Now let's go back to the rest of the problem. All right, for the rest of the polynomials, we have a 1 in front of the p squared, so we have to do that long process. But still, we have to think of two such numbers. All right, so for p squared plus 4p minus 45, we have to think of two numbers and add to 4, but at the same time multiply to negative 45. Can you think of those two numbers? Let's see what symbollab.com says. And here it says p minus 5 in parentheses times p plus 9 in parentheses. So p minus 5, p plus 9. All right, now on the bottom we have a p squared plus 3p. Notice we have just two terms here, which are p squared and 3p. So for this one, the only thing we can do now is maybe take out common factors. So there's a p in the first term and a p in the second term, so we'll take out a p and figure out what's left. So we ask ourselves, p times what is p squared? Well, that'll be p. And then p times what is 3p? Well, that'll be 3. Let's check it out. P times p is p squared, yes. And then p times 3 is 3p, yes. Okay, so we factored everything down. Now, once we factor everything down, I like to think of factors as single people, and single people are available and ready to go out with each other and have a wonderful time. So let's see if we can make that happen for some lucky factors today. The first factor today is p plus 3. It's available. So hopefully there's a factor of p plus 3 in the bottom, and there is. So they go with each other and have a wonderful time. Let's hook them up on their date. Have a good time. Next is the factor of p minus 7. It's available. So hopefully there's a p minus 7 in the bottom, but there's not, unfortunately. So p minus 7 will have to wait for another time. So let's go to the next factor of p minus 5. Guess what? It's available. Hopefully there's a p minus 5 in the bottom, and there is. So hook them up. Congratulations. Next factor is p plus 9. It's available, but no p plus 9 in the bottom. Next factor is 2p plus 3. You're right. They're available, but there's no 2p plus 3. Next factor is p, another available factor, but there's no p in the top. So we're done with all the matchmaking for this problem. And now we'll have to multiply it all up and get the answer. So we have a p minus 7 times p plus 9 all over 2p plus 3 times p. Now let's multiply all these things together. All right, p times p is p squared. P times 9 is 9p. Negative 7 times p is negative 7p. Negative 7 times 9 is negative 63. And that's going to be all over. Let's see, we have a 2p plus 3 in parentheses times p. All right, let's see, that's going to be a 2p times a p, which is 2p squared. Plus, that's a 3 times p, which is 3p. All right, so that's going to be p squared plus, let's see, 9p minus 7p is a 2p minus 63 all over 2p squared plus 3p. And since we cancel all the factors, then there's nothing more we can simplify, even though it looks like we might, but we cannot. And so this is our final answer, p squared plus 2p minus 63 all over 2p squared plus 3p. And that's how to divide two rational expressions.